This is video 4 for the computer programming nodes. For this one, let's start talking about potentiometers. These are basically devices used to measure angular positions of an axle or a shaft that's passed through its center. The center of the sensor can rotate through about 265 degrees, and it has output ratings from 0 to 1023. So if I were to make a circle, since it passes through 265 degrees, we start off at 0, go to 90, 180, 270. So 265 would be right before 270. So this device can spin through roughly this part of a circle. And if we got our ranges in, since the 0 to 1023, these are just basically numbers. It's kind of like how setting a motor port equal to 127 would work. So let's take a look at how this is mounted on the robot. Here we have our potentiometer, and we can see that we got a drive shaft going through it. Now again, these are not designed to make a full rotation, so you have to be careful when you decide to mount one of these. It's just for maybe half a turn rotation, something that's going to spin a little bit. And basically, looking at the way this does is it provides feedback about the position of the arm. And again, when you mount this, you want to make sure that you mount it in such a way that you don't break the device. We can then go through some gearing, and you can play around with how you have this mounted in different places. Again, just making sure that it doesn't go farther than a 265 degree turn. Now let's take a look at some code here. This first line you don't have to worry about. So we're going to start with a while loop, and we got our square brackets for the while loop here and then down here. Then we're going to use nested if statements or embedded if statements. So first off, we have our first if statement, if vexrt channel 5 equals double equals 127. So basically what that means then is if that button is pressed. So if that happens, if that statement is true, then we go into another if statement. Then if, now the way we program the potentiometer is we go ahead and plug it into an analog port, and this one has already been given a name, arm potentiometer. So if that sensor value, and you can plug in instead of putting arm potentiometer, you can, I think it's analog port 4 or something like that. So if the potentiometer is less than 900, now remember, these have values between 0 and 1023. So if it's less than 900, then we're going to turn motor port 6 at power of 31. Now, if this is false, if the button is not pressed, then we have our else statement, which says basically do nothing. Now, if we have a different button pressed, so maybe you want it to turn backwards, then we have our, if that statement is true, then if this is less than 550, again remember this is between 0 and 1023, then we can have the motor move in a negative direction, and then else, if nothing's happening, then you want it to turn off. So basically, these has this, depending on which these two buttons are pressed, this motor will spin between values of 550 and 900, which can be useful. So it can help you make sure that you're not going past a certain point. And you'd have to do some testing to figure out, what 900 is, what 550 is. You just have to, guess and check until you figure out those values. Okay, the next type is an encoder of types. It's very similar to the potentiometer, except it can spin through 360 degrees. It's a continuous thing. Basically, it can measure the rotational speed. It can also distinguish between clockwise and counterclockwise, which is really nice. So what you could do is you can put encoders on the left and right side of your robot, as shown here, and then during the autonomous period, you can use feedback from those encoders to try to make sure your robot travels in a straight line path. So another thing you can use them for is making a turn. So this particular code here will help the robot make a left point turn. So what happens is you'd have the right encoder, or the encoder on the right side, count up to 270. At the same time, you'd have the left coder count down to negative 270. So let's take a look at this code. Once again, we're going to use a while loop. And again, we use sensor value. And sensor value is kind of like motor. We go motor and then in square brackets port something. But in this case, we're going to have it set up. You could put port 3 or whatever you wanted to right there. Now this is a little different. So this right encoder, while the sensor value is less than 270, remember this counts up in terms of angles, so between 0 and 360. So we have this statement right here. I believe this means or the left encoder is greater than negative 270. So while that statement is true, we can then have our if statements. So if that right encoder is less than 270, we're going to turn the motor on at 63, else that motor stays off. Then if the left encoder is greater than negative 270, we're going to spin it at negative 63, else do nothing. So again, what this code does is it allows the robot to make a turn. And it will stop when it's made a 90-degree turn. Now let's say we want to drive straight in reverse. So for this code, it's going to make 5 full rotations. Now, if you take 360, multiply that by 5, you get 1,800. So you can start to do a little bit of math like this, thinking how many 360-degree turns do you want to make? So 360 and then just multiply by 2, 3, 4, 10. So to make 10 rotations, it would be 3,600. So this robot's going to move straight by monitoring the encoder counts on both sides of the wheels and then make adjustments. When one side of the robot has reversed more than the other side, it slows down the speed and speeds up the other to correct the movement to keep the robot moving in a straight line. So this is an example of using the encoders to drive in a perfectly straight line. So again, we're going to start with a while statement. While the sensor value, and then this right here is just whatever port that sensor is plugged into. So while this is greater than negative 1,800, so that means it's going to go in reverse 5 rotations. So then, we're going to use an if statement, and our true or false statement. If the left side is less than the right side. So in other words, if the left side is moving faster than the right side, then we have this code right here. What that does is it slows down the left side and it speeds up the right side. Okay? If the left side is greater than the right side, so if the right side's moving faster than the left side, then we have this amount of code right here that would speed up the left and slow down the right. Now these are all negative because this code is for moving backwards. Finally, let's say the left side is moving at the same speed as the right side. Well, we would want the motors to move at the same speed. And again, this code, you'll notice there's no wait one capital M SECs. We don't need that because it's going to go for 5 rotations. So the motors are going to spin 5 times and then stop. That's the reason why we had this first while statement. So these codes can be really, or these encoders can be really, really helpful if you want to drive in a perfectly straight line for so many rotations. All right, now let's talk about some touch sensors. The first one is going to be a bumper switch. So it's a program, instructs the robot to move forward at half speed until the bumper sensor is pressed. Then this is also written with like a 2-second pause at the beginning of the program. So let's take a look at that. So here we have our main task. This code right here, you can have it if you want to. It's basically, it gives a little pause at the start of the program so you can move everything out of the robot's way. And we're going to use a while statement. Now instead of while true or while 1 double equals 1, we're going to have the sensor value and then touch sensor, whatever port. Again, you can put port, whatever you plug that touch sensor into. And then we have our motors turned on the left, or turned on at half power. So basically this robot will move forward indefinitely until the button is pressed. Because if you look here, while it's equal to 0, so in other words, when that bumper switch is not pressed, this program will do nothing. It'll just keep moving and moving until it runs into something. And once that bumper switch, once this equals 1, then that while statement is false, and then the motors turn off. Here's another one. This one is to wait for a push. So in this one, the robot is waiting for the touch sensor to be pressed. And then once it's pressed, it's going to move forward for 1.5 seconds. So again, we're going to have a while statement, a while loop. We got our main task here. And while this sensor value equals 0, in other words, while it's not pressed, the robot's doing nothing. However, once this becomes a 1, once that switch is pressed, remember switches give us a value of 1 or 0, once this statement becomes false, and then the compiler moves on to this next line, which has the robot move forward at half power for 1.5 seconds. This next one is a wait for release. So here the button is being pressed, but once the button is no longer pressed, it stops moving. So again, we have our main task. Again, we have this little wait program just telling give you some breathing room basically. So let's take a look at this. First we have a while statement. So while it equals 0, remember 0 is when it's not pressed, the robot's doing nothing. However, as the button is being pressed, the robot is moving forward. So in this code, if you have your thumb on the button, this robot's going to be moving. Once you release the button, the robot stops moving. This might be helpful if you used one of those limit switches and you have an arm or something moving. So maybe gravity comes down, it presses the switch, and then it lifts up, and then turns off, and then gravity brings it back down or whatever. The ultrasonic rangefinders, these are kind of a fun one. Basically, they use ultrasonic sound waves and kind of like echolocation to determine how far in front of an object the sensor is. So here's an example of this. There's an object in front of our sensor. The sensor sends out these sound waves that's going to travel, bounce off, and return to the sensor. And using this data, the robot can tell then how far it is in front of some sort of object. So let's take a look at the code here. We've got our main task. Again, this one just has some breathing room, has a 2-second delay before the program kicks in. This just reverses the polarity of motor port 2. You can do the same thing by putting a negative in front of it. And this is actually pretty easy code. Using the while loop. So while the sensor value and then whatever port it's plugged into is greater than 3. So in other words, while that sensor is more than 3 inches away from an object, the robot moves. Once this statement becomes false, this while statement, so once it gets less than 3 inches away, the motors will turn off. Now, these sensors do come with limitations called a cutoff or a threshold. And basically, even though there are many possible values for the encoder counts or distances, they'll either fall below or above that threshold. So in other words, you can be too far away from an object and the robot wouldn't see it with that ultrasonic rangefinder. So you have to be careful about using these. And also, you want to be careful about the type of object that you're trying to see. If it's a thin pole, this ultrasonic rangefinder might not find it. All right, that's going to conclude this unit's worth of notes.